everybody, welcome back to Leetcode Simplified. I'm Alan and today we'll be solving Leetcode 191, number of 1 bits. The task is simple. Given a positive integer n, return how many set bits, that is how many ones appear in its binary representation. This is also known as the Hamming weight. For example, given integer n equal 11, its binary string is 1011, has 3 ones. There are several ways to solve this problem. The first idea most people have is the straightforward one. Convert the integer into a binary string, then simply count the number of ones. Let's submit. Accepted. Great. Simple, readable, and it gets the job done in a different way, equivalently. But we can do better. Instead of working with strings, we can go straight to bit manipulation. That's where the real magic happens. One classic technique is to repeatedly check the last bit of n, then shift n to the right until it becomes 0. Each time the last bit is 1, we increment our counter. Let's implement that idea. First, initialize count to 0. Until n becomes 0, do n and 1 get 0 or 1 depends on the last bit of n. Add it to count. Then shift n right by 1 bit. Repeat until n becomes 0. At the end, count will be our answer. N and 1 equal 1 or 0 depend on the last bit of n. If the last bit of n is 1, then 1 and 1 is 1. If the last bit of n is 0, then 0 and 1 will be 0. So add this to count becomes 1. Then we shift n right by 1 bit to make the next bit ready for next iteration. After shifting, repeat n and 1 is 1 plus to count 2 and shift n right by 1 bit ready for the next step. After shifting n and 1 is 0, add to count still the same 2. Now shift n right by 1 bit, get the last bit ready for next iteration. After shifting, repeat n and 1 is 1 plus to count becomes 3. Next, shift n right by 1 bit, n now becomes 0. Loop ends, count now hold the number of 1 bits. Okay, let's submit this version. Alright, accepted. Wonderful. This algorithm runs 32 times for 32-bit integer. And finally, we look at the optimal solution, Brian Kernighan's algorithms. Here is the clever trick. Turns the rightmost set bit 1 to 0 until n becomes 0. How? N minus 1 flips the rightmost 1 and all bits to its right. And n with original n will turn the rightmost 1 of n to 0. Increase count. N minus 1 will flip the rightmost 1 and all bits to its right. Then AND it with the original n will turn the rightmost 1 to 0. Increase count. Repeat with the new n. N minus 1 flip the rightmost 1 and all bits to its right. Then AND it with the original n will turn the rightmost 1 to 0. Increase count. Repeat with new n. N minus 1 flip the rightmost 1 and all bits to its right. Then AND it with the original n will turn the rightmost 1 of n to 0. Increase count. N now is 0. Loop n. Count is our answer. As you can see, the number of times it repeats is exactly the number of ones in n. Super efficient and a neat piece of computer history. Alright, it's time to smack the submit button. Boom, accepted. So there you have it. 3 different ways to solve Leetcode 191, number of 1 bits. If you found this explanation helpful, don't forget to subscribe and check out the playlist for more Leetcode problems explained simply and clearly. I'm Alan and this was Leetcode Simplified. Thanks for watching. I'll see you in the next one.